Alright, let's look at the homework 3.8, problem number 1. Alright, so let's do that. Alright, it says that the culture of bacterium initially contains 50 cells. So initial population, so I'm going to just call it P0, right? So P0 is 50, right? So we got that. And introduced into the nutrient broth, and it grows at the rate of proportional to its size. Okay, so it's exponential function. Then after 1.5 hours, so if you have P of 1.5 is 3/2, is going to be 775. Right, we have that. Then we want to find population function. All right, so let's do that. So we know that here, this is the key, it grows at the rate proportional to its size. So we know that it's going to be exponential function. So we have P of t is equal to, so we already know P0, so it's 50. And then you have e to the kt, so we need to figure out the k. But since p of 3/2 is equal to, let's see, 50 e to the k times 3/2 is equal to 775, right? So let's solve for k. So this is going to be equal, let's see. So first I'm going to eliminate 50 by dividing through by 50. So you have e to the k times 3/2 is equal to, right, 775 over 50. Right, so what's this? Divide by 5. 7 has 1 5 in it, and then 5 times 5, so 25, and then 25. So 155 divided by 5 is 10. We can still divide by 5, so it's going to be 331 divided by 5 is going to be 2. So it's going to be 31 over 2. Alright, let's solve for k. So first step is I'm going to take the natural log. Right? Natural log and exponential function cancel out, so you're going to get the 3/2k. Then you have a natural log of 31/2. Alright, then we can just, since I want to get rid of 3/2, multiply by its reciprocal, so 2/3. So we end up with k. So you have 2/3 times natural log of 31/2. Right? Let's get this value using a GeoGebra. Alright, so I pull out the GeoGebra here, and we need to compute, let's see, 2/3. Right, 2/3 times natural log of 31/2. Right, so we have that, and I guess I have to change the decimal point. So setting. Alright, so let's see. I can't really see it here. Alright. Alright, so decimal point, so there's going to be maybe 4. Alright, then I'm going to close that. Alright, so it's k value is 1.8272. So I'm going to put 1.8272. Alright. So let's type it in. Alright, so we know that the P is 50. Then we have e to the, alright, then we found k value to be 1.8272, then t. Alright, let's check the answer. Alright, it came back and looks like we got part A correctly. Right, part B, since we already have P of t given, and you just have to plug in 6 there. I'm going to just use the GeoGebra to do it. So here we have a GeoGebra, and then I'm going to define P of t here. So how about P of t is equal to 50 times e to the 1.8272 t, right? So hit enter. So we have a function, and then we want to find P of 6 and hit enter. Alright, so it looks like we want nearest whole number. So we have 2885541. Right? 2885541. Is that correct? Let's see. Alright, 2885541. Alright, so let's check the answer. Alright, I came back and looks like we got part B correctly. Alright, if you want to find the P prime of 6, you can actually take the derivative of this and plug in 6. And there's a shorter, easier way would be, since we know that differential equation is P prime is equal to K times P, right? Because the rate of change is proportional to the population itself. So if you want to find the P prime of 6, then all you have to do is multiply K and P of 6 together, right? So I'm going to just, remember the K, we found that to be 1.8272, and then you just have to multiply by P of 6, right? So let's bring this up, right? Then, here, and I'm going to just make it a little bit smaller. Right, so I need to compute 1.8272 times and P of 6. So P of 6 we can do, so I'm just going to do P of 6. Right, hit enter. Right, so we get 5272460. Right. 5272460. I just can't remember. Right. 5272460. So 5272460. Right, would be the value of P prime of 6 approximately. Right, let's check the answer. Alright, it came back and looks like we got the part C correctly. Alright, so let's move on to part D. Alright, after how many hours will the population reach 250,000? Alright, so let's do that. So we have to do, alright, 250,000. So we have the population function already. So you have a P of t is 50. E to the 1.8272t, and we want this to be 250,000. Right? Right. Then we just have to solve for t. First step would be I'm going to eliminate 50, so divide through by 50. So you have e to the 1.8272t. Is equal to, right, divide by 50, so knock out the zeros, and so it's going to be 5,000. Right? Then we need to eliminate e here, or bring the t down, so we take the natural log. Right? Then that will get you 1.8272t is equal to natural log of 5,000. Right? Then all we have to do is we can just divide through by 1.8272 to get the t value. So natural log of 5,000 divided by 1.8272. Right? So let's try to get the value there. Right? So bring out the GeoGebra there. All right, so we want to compute natural log of 5,000 divided by 1.8272. And then what we get is about 4.6613. All right, so let's type it in. All right, so it looks like TR around to the 1 decimal places. So 1 decimal places would be 4.7, right? So it's going to be 4.7. Right, let's check the answer. All right, I came back and looks like we got the last part correctly. All right, that's it. I hope that this was clear.